Okay, our last example today of f of x equals sine of 50x. First thing I want everybody to do is go to your mode. And I want to make sure that everybody is in radians. We don't use degrees in calculus, we only use radians. So you should never ever be in degrees in calculus. If you're taking physics, is physics out for this year? Yeah. If you're taking physics, physics uses almost exclusively degrees. Make sure that you switch back to degrees for physics, you switch back to radians for calculus. Okay, I've had calculus students in the past have trouble with that. They're using the same calculator for both classes. So be careful that if you're in a physics class, you're using degrees. If you're in a calculus class, you're using radians. I can't remember any calculus problems that are in degrees. I think everything's radians. And that only has to do with trigonometry, sine, cosine, tangent. That's where it matters. If you're doing 9 times 9, it doesn't matter what you're in. All right, so go back to y equals, we're all in radians. And I'm going to graph sine of 50x. Sine 50x. All right, and where do we start?
You don't know. So.
Standard viewing window, right? So zoom 6. This should be fun. Looks like a zipper.
It does. Mine did not.
Yours doesn't look like a zipper, Colin?
Mine's just a straight line.
Did you type in sine of 50x?
Yeah.
Are you in radians?
Yeah.
Did you hit zoom 6?
Probably not. Nope. There we go. There you go. There. Yes, you go.
It doesn't have to be beautiful or perfect, just draw what it looks like for the most part. All right. Now, how high do you think that goes and how low do you think it goes?
1.
Yeah, 1 and negative 1, right? We know that already because sine of anything, the biggest to be is 1, lowest is negative 1, right? So as far as y minimax, let's go 1.5, negative 1.5. So we're not completely at the top of the screen, but we got some room. Now, it looks like it repeats itself a lot. So let's make x smaller. So let's just kind of zoom in like on this little area here. All right, so if we do that, window, let's go from negative, let's say 1 to 1. Let's see what happens there. And let's go negative 1.5 to 1.5. Hit graph again, see what happens. Now it looks like a bigger zipper, doesn't it? Okay, so that's not perfect. What we're looking for sine is a picture that looks like this. A nice little sine curve. Like we had last year in geotrig, right? So it looks like it repeats itself a lot. So what do you want to go for window for x? It's got to be smaller than negative 1 and positive 1.
0.25.
Negative 0.25 to 0.25. Hit graph again, see what happens. Getting better. And that might be good enough for you. That might be, well, that's only 1, 2, 3, 4 periods of it. It's pretty good. If we want to get a little closer, maybe negative 0.1 to 0.1. See what happens. And there's no real math to this. It's just a matter of playing around with it and getting to a point where it looks like what you want. To me, that looks pretty good. So, my final picture. Negative 0.1 to 0.1, negative 1.5 to 1.5, x-axis, y-axis.